Welcome to Astronomy Daily, your source for the latest news in space and astronomy. I'm your host, Anna, and today we've got a fascinating roundup of stories covering everything from orbital debris concerns to lunar missions and Mars exploration. We'll be exploring some groundbreaking developments that are shaping our understanding of the cosmos and humanity's ambitious ventures beyond Earth. Our first story today highlights a growing crisis above our heads. The recent breakup of the Intelsat 33E satellite has added another troubling chapter to the mounting space debris problem. This broadband communications satellite, positioned about 35,000 kilometers above the Indian Ocean, suddenly lost power and broke into at least 20 pieces, according to U.S. Space Force's confirmation. This incident adds to an already critical situation in low Earth orbit, where we currently have an estimated 13,000 metric tons of space junk circling our planet. It's a stark reminder of what scientists call the Kessler syndrome, a scenario first proposed by NASA scientists in 1978, where the density of objects in orbit becomes so high that collisions create a cascade effect, generating more debris and more collisions. The numbers are staggering. The European Space Agency's Space Debris Office estimates there are about 40,500 objects larger than 10 centimeters in orbit, plus an additional 1.1 million objects between 1 and 10 centimeters, and a staggering 130 million pieces smaller than a centimeter. Back in 2009, Donald Kessler himself declared that the orbital situation had already reached the point of instability. While tracking technology is improving and various solutions are being developed, including missions like ADRAS-J and ClearSat-1 designed to actively remove debris, the challenge continues to grow. The Intelsat incident underscores the urgent need for better frameworks to prevent future collisions and address the removal of existing space debris. Without effective action, we risk compromising our ability to safely operate in Earth orbit, potentially impacting everything from communications to scientific research. Next up today, let's get a Mars update. In what can only be described as a fascinating astronomical spectacle, NASA's Perseverance rover has captured an eerie and remarkable sight from its vantage point in Mars's Jezero crater. The rover witnessed Phobos, one of Mars's two moons, passing directly between the Sun and Mars, creating what looks remarkably like a cosmic googly eye in the Martian sky. This rare transit occurred on September 30th, during the rover's 1,285th Martian day of exploration. Using its advanced Mastcam-Z camera system, Perseverance recorded the potato-shaped moon as it partially blocked the sun's disk, casting its shadow, known as the antumbra, across the red planet's surface. To put this celestial dance in perspective, Phobos is quite tiny compared to our own moon, about 157 times smaller, in fact, measuring only 17 miles across at its widest point. Despite its small size, these transits are relatively common on Mars because Phobos orbits very close to the planet's surface and almost perfectly along its equator. The moon completes an orbit every 7.6 hours, which means these transit events typically last only about 30 seconds. What makes this observation particularly valuable is that it helps scientists refine their understanding of Phobos's orbital dynamics. By comparing images of these transits over time, researchers can track subtle changes in the moon's orbit. Current calculations suggest that Phobos is gradually moving closer to Mars and is predicted to collide with the planet in approximately 50 million years, a cosmic blink of an eye in astronomical terms. This isn't the first time NASA has captured such an event on Mars. Several rovers, including Curiosity and Opportunity, have witnessed similar transits over the years, but each observation adds another piece to our understanding of Mars' complex system of moons and their ultimate fate. Speaking of things colliding with planets, for those who've long viewed comets as mysterious harbingers in our night sky, scientists are now developing an innovative approach that could revolutionize how we detect these celestial wanderers. By studying meteor showers, researchers believe they can predict the orbits of potentially hazardous long-period comets years before they become visible to our telescopes. The connection between meteor showers and comets has been well established. Those spectacular shooting stars we see during events like the Perseids or Geminids are actually debris trails left behind by comets crossing Earth's orbit. But until now, astronomers have typically worked forward from known comets to identify meteor showers. This new research flips that approach on its head. Using sophisticated computer simulations, scientists have demonstrated that by carefully analyzing meteor shower patterns, they could potentially trace them back to their parent comets, even when those comets are still far from the inner solar system. With the upcoming Rubin Observatory's powerful sky-scanning capabilities, this method could provide crucial early warnings of approaching comets. The team's simulations covered comets with orbital periods ranging from 200 to 4,000 years. While not all comet orbits produce useful shower patterns, the researchers identified 17 scenarios where meteor shower observations could help locate their parent comets months or even years before traditional detection methods would spot them. They've already put this theory to the test with real-world data. Looking at the Sigma Hydrid meteor shower, which appears each December, researchers found they could have predicted the arrival of Comet Nishimura 8 months before its actual discovery in 2023. This practical demonstration shows just how powerful this new detection method could be for planetary defense and our understanding of these ancient solar system visitors. Next up, news from China's rapidly developing space program. A fascinating space race is heating up between China and the United States, but this time it's not about putting humans on another world. It's about who will be the first to bring pieces of Mars back to Earth. China has recently announced plans to accelerate their Mars sample return mission, aiming to launch Tianwen-3 in 2028, 2 years earlier than previously scheduled. This ambitious mission will require 2 separate launches using China's Long March 5 carrier rockets. The plan involves not just landing on Mars, but also collecting samples, launching them back into Mars orbit, and then safely returning them to Earth, all within the same year. China's approach draws on their successful lunar sample return missions, including their recent Far-Side moon sample collection. Meanwhile, NASA's Mars sample return mission, a joint effort with the European Space Agency, continues to face scrutiny and challenges. The project is currently under review, with teams working to find a way to bring samples back before 2040 while keeping costs under $11 billion. These samples would come from carefully selected cores currently being collected by the Perseverance rover in Jezero crater. The scientific community has mixed feelings about this competition. While many researchers welcome the prospect of getting Mars samples sooner rather than later, regardless of the source, others express concern about China potentially achieving this milestone first. Some experts are calling this a potential Sputnik moment that could have significant implications for future Mars exploration leadership. China's mission may opt for a simpler grab sample approach, collecting whatever material is within reach of their lander. While this might be less scientifically valuable than NASA's carefully selected samples, the political and technological achievement of being first to return material from Mars could mark a significant shift in space exploration prominence. And another country with aspirations of bringing samples back from a celestial neighbor. India's space program is taking another bold step forward with their recently announced Chandrayaan-4 mission. The Indian Space Research Organization, or ISRO, is targeting a 2028 launch for this ambitious sample return mission to the moon's south pole, aiming to collect around 3 kilograms of lunar material from this scientifically fascinating region. The mission's complexity is remarkable, involving 5 separate spacecraft modules and requiring 2 launches of India's most powerful rocket, the LVM-3. The carefully choreographed plan calls for a lander and sample-collecting ascender to be launched first, followed by a transfer module and re-entry module that will orbit the moon. After collecting the samples, the ascender will launch from the lunar surface and perform a crucial rendezvous with the orbiting modules before the samples begin their journey back to Earth. To prepare for one of the mission's most challenging aspects, the orbital docking of spacecraft, ISRO will conduct a space docking experiment known as SpadeX, either later this year or in early 2025. They're also developing new technologies, including a robotic arm for surface sample collection and a drilling mechanism to gather material from beneath the lunar surface. What makes this mission particularly interesting is its target location near the lunar South Pole, an area rich in water ice that's becoming increasingly important for future space exploration. At an estimated cost of about $250 million, ISRO is demonstrating its ability to achieve ambitious goals while maintaining relatively modest budgets. The Chandrayaan-4 mission isn't standing alone. It's part of India's broader lunar exploration strategy. Plans are already in motion for Chandrayaan-5, a joint mission with Japan that will feature a much larger rover. These missions are stepping stones toward India's ultimate goal of landing astronauts on the moon by 2040 and establishing a lunar base before 2050. Next, as if our skies weren't cluttered enough already, the European Commission has recently announced it's pressing ahead with its ambitious plans for a sovereign broadband constellation, though the project is facing some significant hurdles. The initiative, known as IRIS-2, Infrastructure for Resilience, Interconnectivity, and Security by Satellite, aims to deploy more than 290 satellites by 2030, creating a robust communications network for both government and commercial use. Originally slated to begin global services by 2027, with satellite deployments starting in 2025, the project has encountered delays and substantial cost increases. What began as a €6.5 billion venture has now reportedly ballooned to around €10 billion. The initial funding structure, which called for 60% public funding with the remainder coming from private industry, is currently being reassessed. A consortium called Space Rice, led by major European satellite operators SES, Intelsat, and Hispasat, has submitted what's being called a best and final offer for the project. While the details remain under wraps, the European Commission is proceeding with a 12-year concession contract, though they've noted that additional funding arrangements may be necessary after 2027. The project has also seen some interesting shifts in its industrial organization. European manufacturing giants Airbus Defence and Space and Thales Alenia Space, who were initially co-leaders of the consortium, have now moved into subcontractor roles. This restructuring appears to be in response to price and performance pressures. Despite these challenges, the European Commission remains committed to ensuring the project benefits the broader European space industry. They're maintaining their requirement that at least 30% of larger contracts be subcontracted to smaller businesses, aiming to foster a more diverse and robust space economy across the region. And that brings us to the end of today's space and astronomy news. Thanks for tuning in to another episode of Astronomy Daily. I'm Anna, and I hope you've enjoyed today's journey through the latest developments in space exploration and astronomy. If you want to stay up to date with all the latest happenings in space, head over to astronomydaily.io, where you'll find our constantly updating news feed, complete archive of past episodes, and the opportunity to sign up for our free daily newsletter. While you're there, don't forget to check out some amazing deals from our sponsors. Looking to connect with us on social media? You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Join our growing community of space enthusiasts and never miss an update. This is Anna, signing off until tomorrow's exploration of the cosmos. Keep looking up.